oils. Welcome to my channel. This is AR, and we are beginning section 2.6. That topic is called related rates, and we have 4 new important words for those of you who are not here. But that would be Zeba. So Zeba, this is for you. So you can freeze this while you copy that down, but you are responsible for these next 4 words. All right. So this is where we're headed. And what was really funny is I wrote this before the BP oil spill. So an explosion at an oil rig in the Gulf of Mexico, and I think before that it was an oil tanker, caused an oil to spew forth at a rapid rate, and the oil rose to the surface of the water. I think it's still leaking. I don't think they have closed it. A circular oil slick began to form. Does water and oil mix? No. Who comes to the surface? The oil. So, and it was forming a perfect circle in a perfect world. As more oil leaked out, the area of the oil slick grew. Does that make sense? As the radius became bigger, what happened to the area? It got bigger. The rate of change of the radius caused a rate of change in the area. And believe it or not, those rates can be different. Okay? They are called related rates because the rate of change in one was affected by the rate of change in the other. So our goal today is learn how to differentiate anything with what this time? With respect to time. And what was it yesterday? With respect to x. So in all of our equations, I don't think we're ever going to do that problem, by the way. So you didn't have to write that down. But we will be differentiating with respect to time. Since no variables are going to be time, all derivatives will have a rate, multiply them, and that rate will be with respect to time, and there will be no dx over dx that goes to 1. None of these rates will disappear. Okay? Can I move this up to here? Oh my gosh, what's this the area of? Oh, why did I choose this formula? Yeah, it goes with the oil slick. Don't you love it when things just kind of tie together? All right, so here we go. So, Aiden, did you get this far? Mr. Mack's class? Okay. So you did implicit also. So that wasn't as new when you missed yesterday? Okay. So if I do the derivative of a, it's going to be 1. Agreed? What did we just do the derivative of? What variable? A. And what is the respect to? So that's going to be dt, respect to time. Yesterday it was d what? X. Now, is this product? No. Why? There are not variables on both sides. Pi might look like a variable, but it's not. So this is going to be pi times, what's the derivative of r squared? What did you just do the derivative of? D what? R over dt. And that's as good as it gets. The derivative of area with respect to time is 2 pi r dr over dt. So funny story. Years ago, when I was teaching calculus for the first time, and I got to this chapter, I thought, I don't know how to teach it. So I thought, rather than trying to figure it out on my own, I would go see Mr. Mack. And I would go to see how Mr. Mack taught it. So I go to Mr. Mack. I say, Mr. Mack, how do you teach related rates? And he said, well, we kind of just massage it a little bit, and it happens. Okay. Any more wisdom? Nope, that's about it. So I went back down to my little portable, and I grabbed every calc book I could find, and I did every problem that I could find. And this is what I discovered. When I understood what my variables represented, and when I understood what the rates represented, I could do the problem. Therefore, the expectation, not on the AP exam, but for your homework and for your 2-6 test, is to define all variables and to define all rates. I think it is so important that you literally will get 1 point for each variable and each rate that you define. So that means if you don't do that, then what are you going to lose? Points. All right, so let me get you started with this one. I have a variable r. What does r represent? So this is the radius. When I say define, it's not tell me what number it is. This is the radius. So let's go ahead and define what does dr over dt mean. This is the rate of change of the radius with respect to time. So the beautiful thing here is that now these rates that we played with yesterday, are going to start to make sense. You with me? They're going to start to represent something. Well, there's another variable in my problem, and what is it? A. What is A? Area. What do you think dA over dt represents? Rate of change of area with respect to time. And once you do enough problems of the same type, you start to see patterns that emerge. And as I saw those patterns, then I could say, all right, when this happens, I need to know I need to do this. So that is the wisdom I'm going to impart to you all. I'm not going to massage it. We're going to define our variables, and I'm going to give you some hard, fast truths. But right now, all we're going to practice is derivatives with respect to time. That's my goal today. And if there's any context with our formula, then we're going to define our variables, because that just moves us ahead. So theoretically, I should be able to give you any rate now, and you should be able to tell me what it is, correct? It's going to be the rate of change of whatever this variable represents with respect to time. Emily. Right. If I just give you x and y's, you can't do that. And there'll be a few, but right now, anybody know what this is a formula for? Volume of a what? Sphere. Very good. Now, I'm not asking you to memorize that, because if it's on the AP exam, they will give it to you. Okay? So let's go ahead and let's do this derivative. What's the derivative of v? 1. And what did you just do the derivative of? dv over what? dt. And all of this, today it's all with respect to time, is equal to, is this product? So that's going to be 4/3 pi. What's the derivative of r cubed? 3r squared. And what did you just do the derivative of? dr over dt. Does anything simplify? The 3's perhaps? So you have dv over dt is equal to 4 pi r squared dr over dt. Back to variables. There is an r in this equation. What does r represent? If I gave you a diameter, could you get down to the radius? Okay. So this means we're going to have a rate dr over dt. And what does that rate represent? Rate of change with rate of change of radius with respect to what? What's my other variable? V. So V is volume And it's going to have a rate, which is dv over dt. And what is that? Rate of change of volume with respect to time. Is that an easy 4 points? I think it's an easy 4 points. It's a sad 4 points to lose. Let's just put it that way. If you don't define variables on your 2-6 homework, you will not get credit. Well, you'll get half credit. Yes. Pretty much these are going to be more application problems, and you're going to see that they're going to give you that the rate of change of radius with respect to time is 2 centimeters per inch. 2 centimeters per second. So that per second will help you know. Otherwise, yes. Now, is there anything that's really obvious here as far as what this is supposed to represent? Pardon? That is a circle, you're right, who's centered at 0, 0. But I was thinking of something else for geometry. Pythagorean theorem, yep. All right, but we don't know what x represents, so all we're going to do is this derivative. So what's the derivative of x squared? 2x, and we're doing this with respect to time, so that's going to be d what? dx over dt plus, what's the derivative of y squared? 2y, and we just did the derivative of what? dy over dt, and the derivative of 25? 0. So one of the things I will do is I will move my 2x to the other side, just so the rates are on opposite sides. But solving for dy over dt versus dx over dt is really, one is not better than the other. But what can I do to work smarter and not harder? If I divide by 2, will that keep the arithmetic at a minimum? And you all love arithmetic without calculators, correct? Yes? No. So these are little tricks to help you on the non-calculator portion to help you reduce the amount of arithmetic you have to do. Nicole, Noel. Okay, so let's look at 2x. No. What if I have 4x squared and I do that derivative? What is that going to be? It's the coefficient. So 4/3 pi is your coefficient. Now, if you did product rule, then eventually that would have gone to 0. Okay? But that's the hard way to do it. All right, we can't define variables here because we don't know what they represent. Oh, look at this one. I don't want number 4, and I bet they're all attached. I guess. Oh, no, they're not. All right, so this is the one I want. We'll throw that one up. Ooh, not so hard. All right, let's do this one. And again, there's no defining of our variables because we do not know what they represent. But why do I like this one? Oh, Noel saw it. It is what? Product rule. So we're going to say first times the derivative with respect to time of the second plus the second times the derivative of the first with respect to time. All right, what is the derivative of y squared? 2y what? d what? dy over dt. What's the derivative of 3x? 3 what? dx over dt. Now the good news is when we get into the applications, the derivatives are going to be pretty easy. They won't be this convoluted. All right. What's the derivative of y? 1. And what did you just do the derivative of? dy over dt. Plus y times, what's the derivative of 2x? And what did you just do the derivative of? Okay. So what I will ask you to do is I will ask you to at least get the dy's on one side and the what? Dx's on one side. Is that fair? So I'm going to move I already have 3 dx over dt here. So I'm going to subtract 2y dx over dt because it's an x. In the meantime, I have a 2x dy over dt plus a 2y dy over dt. Now, what could we do on each side? What could we undistribute? A 2 and a what? A dy over dt, which would leave us with x plus y. What could I undistribute on the right side? Dx over dt, leaving us with 3 minus 2y. Again, why is this helpful? I think that you would find addition. You would rather add than multiply, correct? So by distributing or by factoring, I'm reducing the amount of multiplication you have to do. You can combine with addition, you can combine with subtraction, and then multiply just once on each side. So that was the goal. What do you think so far? Do you like this better than yesterday? Do you see it's the same thing, except yesterday was all with respect to x? I'm going to want it factored if I'm just asking for the derivative, I'll want it factored. You see by doing dx over dx yesterday, prepared us for today because these rates never disappear. There's always a method behind my madness, even if you might not see it. All right, so now what we're going to do is we're going to take it up one level. We're going to find a related rate. So we've got our equation. We still don't know what it represents. Oh, that's not a highlight. Oh, I just saved it. You've got to be kidding me. All right, I will have to fix that. All right. So there's our equation. That's all I've given you in the past. What have they given you this time? They've given you an x value. They've given you and what else have they given you? A rate. Now, they're asking you to find dy over dt. So the fact that you have to find dy over dt, that should tell you you need to do a derivative. So let's do it. What's the derivative of x? 1 what? dx over dt. What's the derivative of y squared? 2y what? dy over dt is equal to what? 0. So I've got 2y dy over dt is equal to a negative dx over dt. So what am I going to do with this 2? Substitute it where? For y, right? Where am I going to put this 4? Or dx over dt. So this is going to look like 2 times 2 dy over dt is equal to negative 4. Can you solve for dy over dt now? What will it be? Yeah. dy over dt is equal to negative 4 over 4 or negative 1. What do you think? Is this too easy? No? Yes? Today? No. Okay. I think I have another one. Oh, no. Oh, I will use that horrible word. Yes, that was before I had to supervise math IAs. Oh, that first copy? Oh my gosh, it is riddled with plugs and chugs and plugging and chugging and oh my gosh. And that's one of the things in peer edits that they were looking for. And most of the kids fixed it. Every once in a while I'd see it. And my comment was, really? Okay, here's another one. Here's our equation. I like this equation. Why do I like this equation? Oh, yes. You need to be eagle eye for that product rule. How do we know this is product rule? Two variables. So we'll say x times the derivative with respect to time of y. How do we know we're doing it with respect to time? Plus the second, which is y, times the derivative with respect to time of the first. What's the derivative of y squared? 2y what? dy over dt. And what's the derivative of 3? Okay. So what is the derivative of y? 1 what? dy over dt. Plus, what's the derivative of x? 1 what? dx over dt plus 2y dy over dt is equal to 0. So I'm going to subtract y dx over dt because it's the oddball. And that leaves me with x dy over dt plus 2y dy over dt. And I'm going to choose to factor to minimize my multiplication. So that's going to be x plus 2y. So are you ready for the fun? What did they give us? They told us x is 4, so it's going to come down to that x. They told us y is 1, so it's going to come down to that y. And they told us dy over dt is 5. All right, 4 and 1. So here we go. So this is going to be 5 times, was it 1? I've forgotten already. 4. So 4 plus 2 times 1 is equal. Oh, there's a negative y. I got to plug 1 in there also. So that's negative dx over dt. So that's going to be 5 times 6. So what is dx over dt telling us? Or what is it? Negative 30. This means that whatever this represents, whatever variable it represents, that variable is decreasing, right? Because it's negative. Does that make sense? If it's positive, it is what? Increasing. Yes. Oh, the y, I had to substitute the 1 in for that y also. That one went there also. Yeah, I almost missed it. Well, you can tell I didn't draw the line. All right, so the question is, yes. Oh, I was just saying that this is a rate. No, not really. And this rate tells us that whatever x represents, it's decreasing. So a point is moving along the graph. This is the same thing. Do you need any more examples? I got lots of them. You don't want any more? Are you tired? Look at that. Do you want to do one on your own? You don't want to do that either? Okay, so let's do this. At least start to write this for me. Is that fair? So steps for solving related rate applications. You are going to sketch a diagram if helpful. Okay, and I think instead of number 2, I think we need to add a 1.5. 1.5. You are going to write an equation to fit the situation, to fit problem. Oh, okay. That is the same thing as number 3, and it's typed. So what we're going to do is I'm going to move 3 up here, and we are going to call that 2. Oops, or not. Goal is to call this 2 and to call this 3, because you really need an equation to write down the variables, write down all variables along with the rates that will be produced and explain the rates. That means define them. Okay. 3.5. Anything that remains constant. Anything that remains constant. You can substitute a value for. This is one of those little special things I learned. But it must be constant. That means it never, ever changes. If it changes, you can't substitute. Then you'll differentiate with respect to time. Oh, and there's that awful word. Yes. I learned that from a science teacher. I should have known better. And then substitute. Known values and solve for the unknown. That really puts us ahead for the next lesson. Now, Rachel was smart enough to download these notes. And the reason why that's really helpful is she is not going to have to copy down all the word problems that are following. So I just want to make a statement. Oh, so was Anisha. That I suggest that you download this lesson because all of the problems from here on out are going to be word problems. Okay? And that way you have the problem and you can do the problem in that space provided. Does that help? Strongly urge you to download this lesson and print it. Section 2.6, related rates. This is all 2.6. So what I'm going to do next time is we're going to be able to start with our problems. So I probably should I'm going to send a remind out for C Day. I better wait because you're still copying. When I stop this, it's going to block most of that. And what you'll see below number 5 are lots of formulas. Formulas that you're going to need to do your homework with. But the formulas that I did not give you on important words, I would give you on the test. Are you with me? But it doesn't help you on your homework unless there's somewhere where they're written. So you're going to need to refer to that. So what are you going to do for Friday? You're going to have the notes downloaded.